Today, we're going to decode one of the body's most fundamental mysteries, the rhythm of the human heart. For centuries, all we had was a sound, a feeling, a pulse. But the heart's true language, well, that was completely silent.
So you can imagine the problem facing medicine back in the late 19th century. The heart is obviously beating, but what is it actually saying? How could you possibly translate a rhythm you can feel into a language you can understand?
Back then, doctors were masters of the mechanical stuff. They could feel a pulse, they could hear the thumping valves with a stethoscope. You get the picture. But here's the thing. All of that was just the aftermath, the effect. The real cause, that tiny, precise electrical signal orchestrating the whole symphony, it was completely invisible, totally unheard. It was a language with no translator.
But that kind of silence, it really gets under some people's skin. And there was this one guy, a physician and a scientist, who was convinced that biology had to play by the same rules as physics, and he was about to change everything.
That man was Willem Einthoven. Working in his lab at the University of Leiden, he just knew the heart had an electrical voice. He watched other researchers try and fail with these clumsy, crude instruments that just mangled the signal. So he thought, okay, this is all wrong. He realized you couldn't force the biology to fit the tool. You had to invent a new tool that was sensitive enough to listen to the biology.
And you know what? With incredible patience and ingenuity, that's exactly what he did. He built a machine that could finally hear the heart's silent language. And not just hear it, but write it down for the whole world to see.
He called it the string galvanometer. Now, the core of this invention was an impossibly thin quartz string coated in silver. I mean, we're talking so incredibly delicate that the minuscule electrical current from a single heartbeat was enough to make it vibrate inside a magnetic field. Nothing like it had ever existed.
But here's the real stroke of genius. How do you even see something that tiny vibrating? Well, Einthoven shot a beam of light at it, and the moving shadow of that string was recorded on a photographic plate. Just think about that for a second. He was turning an invisible electrical pulse into a visible, permanent line. He was taking a quiet whisper and turning it into a written word.
And when he looked at those first kind of messy recordings, he saw something absolutely extraordinary. Amidst all the noise, there was a pattern, a distinct repeating shape, a series of peaks and valleys that showed up with every single beat. To start making sense of it, he just gave them letters, P, Q, R, S, and T.
And you have to understand, this was so much more than just a measurement. It was a language. Each letter, each little wave, it meant something. It corresponded to a specific part of the cardiac cycle, the squeezing and relaxing of the heart's chambers. For the very first time, the heart's electrical story could actually be read.
Okay, so inventing an alphabet is a huge deal. But what good is it if no one else knows how to read it, right? The next big challenge was getting this remarkable discovery out of the lab and into the hands of doctors. So to do that, Einthoven created a system. We now call it Einthoven's triangle, and it was basically a standardized way to place electrodes on a person's arms and legs. This was crucial because it meant a recording taken in Amsterdam could be reliably compared to one taken in New York. It's what turned a cool experiment into a reproducible clinical tool.
Now, it wasn't an overnight success. Far from it. Doctors were skeptical. The original machine was a beast. It took up an entire room. And get this, the process was a pain. Patients had to stick their hands and feet into buckets of salt water just to get a good connection. Yeah, not exactly convenient.
But the results? They were simply undeniable. Conditions that were once diagnosed just by feeling an irregular pulse, like arrhythmias, now showed up as clear, jagged patterns on the page. Mysterious issues like heart block suddenly left a distinct, visible signature. The ECG gave doctors cold, hard, visual proof for things that had been invisible.
And that was the monumental shift. Medicine could finally go beyond just listening. It could now read the electrical commands directly. It was a move from subjective guesswork to objective data. A whole new era of diagnostics had just begun.
Einthoven's discovery didn't just change medicine in his lifetime. It created an echo that is still resonating through every single hospital in the world today.
In 1924, the world made it official. Willem Einthoven was awarded the Nobel Prize in Physiology or Medicine for his discovery. It was formal recognition that he had essentially given medicine a powerful new sense.
And just look at the journey since then. It starts in 1903 with a machine that fills a room. By the 1950s, ECGs are becoming standard in hospitals. And now?
Today, that same fundamental technology fits in your pocket or on your wrist. Every single one is a direct descendant of Einthoven's original vibrating string.
But you know, his greatest contribution wasn't even the machine itself. He never claimed he cured the heart. He gave medicine something much more fundamental. He gave us understanding. For the first time, we understood the electrical rules of the game. And that understanding became the foundation that all of modern cardiology is built on.
Einthoven's quest to translate a silent biological signal into a readable language, well, that story is still playing out today in countless fields of science, and it leaves us with the final thought. What are the quiet, invisible processes happening right now in our own bodies and in the world around us, whose alphabets have we just not discovered yet?